Coming up in this edition of Above and Beyond, John Glenn blasts off on board Friendship 7 in 1962 to be the first American man to orbit the Earth. We take you on board the Mercury spacecraft to witness this historic journey from blast-off to splashdown and outline other accomplishments from 1962. And in 1885, two brothers flew across the roofs of Paris in a balloon. In 1934, balloon flight had become far more sophisticated due to this man, Professor Jean Piccard, who developed the pyrotechnics that are deployed in space applications to this day. This man, his wife, and his brother were, in every sense of the word, trailblazers. (1962) is the year that John Glenn makes the first US spaceflight around the world on February the 20th. Friendship 7, with astronaut Glenn aboard, waits atop the 93-foot-tall Atlas vehicle. The countdown reaches the final seconds.
Roger,
55 seconds after blastoff, everything is going fine for John Glenn. Four minutes and 8 seconds into the flight. This is what the arduous training has been all about. The astronaut's eyes dart from one instrument reading to the next. He reports that everything looks good. Five minutes and 3 seconds have elapsed. Ground control tells Glenn that the capsule is turning around, and he reports that he sees it, and as the booster comes into view, he declares it to be beautiful. Astronaut Glenn is in orbital flight, 100 miles in space. His voice reports are accurate, coherent, and prompt. The space pilot has no problems reaching for controls. Chewing and swallowing food is easy. Glenn experiences no vertigo or nausea, even as day turns into night 17 times faster than normal. On the night side, the pilot reports the horizon is always visible. At the end of the first orbit, a malfunction in the automatic control jets occurs. The problem continues throughout the rest of the flight. This glitch is an opportunity to prove man can take full control of the spacecraft. On the third orbit, after manually maneuvering the spacecraft, the retro rockets fire when the craft is just off the coast of California. There are heat shield problems too. At 4 hours and 38 minutes, ground control recommends that the retro package should not be jettisoned. This means that Glenn will have to override the switch at 04:43:53 in 4.5 minutes time. This also means he'll have to retract the scope manually. Friendship 7 arcs down into the Earth's atmosphere. As it decelerates, the effect of ionization around the spacecraft temporarily blocks communication. The heat shield is about 3,600 degrees. Glenn's heartbeat is only slightly accelerating. He's then informed that the expected splashdown is within 1 mile of the awaiting destroyer. The spacecraft vibrates excessively. The drogue parachute deploys earlier than planned, stabilizing the craft. 9 minutes before landing, the recovery forces begin searching the landing area. The destroyer, the USS Noah, has the spacecraft in sight. After 4 hours and 56 minutes, astronaut Glenn and the Mercury capsule complete the first United States manned orbital spaceflight. 18 minutes later, the USS Noah recovers the spacecraft from the sea. Post-flight examination shows the astronaut is in excellent health. John Glenn has left his mark in history. In February 1962, wooden mock-ups of the Apollo lunar mission spacecraft are on hand and other tests are underway. Workers test sample materials for Apollo at high temperatures. Scientists try out ablative heat shield materials of resin, micro-balloons and nylon. Temperatures are from 2600 degrees Fahrenheit on the side facing the quartz lamp heat source to 420 degrees on the other side. Construction of wooden command module mock-ups begins early in February. Scientists make electronic and computer studies. Mock-ups of cabin interior arrangements aid in the design of Apollo modules. Wind tunnel testing is a key factor in the early development of Apollo spacecraft. Workers test a command module and launch a skate tower test model in a 20-inch wind tunnel. Airflow goes to Mach 3.05. Meanwhile, astronauts train with the re-entry simulator trainer at Langley, Virginia. Returning from a moon mission, the guidance system can guide the spacecraft from re-entry into the Earth's atmosphere to either the prime or alternate landing point. In addition to John Glenn's achievement, 2 more Mercury orbital flights are successful in 1962. Astronaut Carpenter flies 3 orbits on May 24. And Girard does 6. He declares he's about to fly by wire. He will take the controls. Then adds that everything is handling nicely. The powerful Saturn rocket completes its first 2 test flights as the Apollo program rolls on. And NASA launches the first active communications satellite, Telstar 1. Workers put NASA's relay communications satellite in orbit. Another highlight of 1962 is the first launch of an international satellite. It's Britain's Ariel 1, which NASA places in orbit. That satellite takes measurements of the ionosphere. In 1962, on December 14, Mariner 2 becomes the first probe to fly by another planet. It flies within 32,400 kilometers of Venus, scans its surface, and takes temperatures. NASA puts 2 more Tyros weather satellites into Earth's orbit, and use of weather satellites is nearly routine, with the Weather Bureau using satellite data to help predict weather. NASA adds more astronauts to its roster. On September 17 in Houston, 9 new astronauts are presented to the public. NASA selects them after more than 6 months of evaluation from 200 volunteers, both military and civilian. The new candidates are to start training with emphasis on space navigation, computer theory, and aerodynamic guidance and control. In 1962, miniature components for the Mercury capsule are examples of some of the developments with potential for other uses in industry and at home. This is a Mercury capsule retro fire delay. It contains 50 components in a case about 3/4 of an inch by 1 inch by 1.5 inches. Preparations continue in the last half of 1962 for the first 2-man Gemini flight, which is to ultimately occur in March 1965. NASA develops more space technology in preparation for Gemini. The Gemini spacesuit can be worn for as long as 14 days. It's being tested for comfort and mobility. Boots, gloves, helmet, when attached to the suit, provide decompression protection during critical times of flight. The Apollo suit is so far the most difficult to develop. Scientists test dehydrated, freeze-dried foods and concentrated bite-sized snacks packaged in edible coatings for space travel use. Water reconstitutes dehydrated food to its original texture. Freeze-dried foods include fruits, meats and fish, which can be stored indefinitely without spoiling. Scientists study how well microorganisms live in a space environment. These studies are important before artificial environments for space crews on extended missions are created. In our next edition, we'll look at the developments during the following year, 1963. Brothers Montgolfier made the very first manned flight above the streets of Paris. In 1934, it was another famous pair of brothers who developed the forerunner of today's pressurized spacecraft. Auguste and Jean Piccard invented a bathyscape for deep-sea research using a pressurized cabin and artificial atmosphere for the first time. Years later, applying the same techniques, they constructed a gondola to be carried by a hydrogen balloon to the stratosphere. Picard balloon flights led to the complete environmental systems without which spaceflight would not be possible. Pressurized cabins are of course necessary, as are the pressurized space suits worn by the astronauts for such times that the cabin is not pressurized, and for EVAs. The Doctors Picard also pioneered the development of other inventions to make possible man's explorations high above ground. For example, pyrotechnic devices. These are explosive systems used for many purposes during spaceflight, separating launch stages and modules, cutting the lines of parachutes after they'd served their purpose during re-entry, blowing open the adapter which protects the lunar module during launch and early flight. In the Apollo spacecraft, there were over 100 such pyrotechnic systems. Here, Professor Picard shows the pyrotechnic device for releasing ballast from a balloon gondola. The blasting cap is placed in the center of the bag, then filled up with sand. Then, from inside, with an electric contact, he explodes the blasting cap and the bag punctures very safely. That particular application was credited with saving the lives of Professor Picard and his wife, who went along with him on flights as official photographer. They are the only people who made the stratosphere flight in the 30s through clouds, landing again through clouds, and lived to tell the tale. The balloon was inflated with 700 cylinders of hydrogen. Just a little gas is needed. This is the difference between a stratosphere balloon and an ordinary balloon. A small amount of gas is put into the top of the balloon until it's about 1/10 full. Now the balloon is fully inflated. It's held by ropes until liftoff. Of the 300 volunteers that gathered to witness the event and help out, only 6 of them had ever seen a balloon before. When the famous balloonist Ed Hill signaled, all the men went forward a given amount so that the balloon went up evenly on all sides. At this stage, they began to be conscious of the stress on the balloon. The lower part was turned up inside, and it was an ethereal sight that presented itself on the chilly morning. The stress on the balloon would have been too great if they'd taken off at this point. The material would tear in flight, so the appendix is opened, allowing air into it, and all the folds are made free and easy. The gondola is moved very carefully under the balloon and attached to the load ring, and the load ring is held by 4 heavy ropes. The white bags above the gondola holding the ropes to the balloon will be severed using lengths of TNT. This is the first pyrotechnic device used to release an aircraft. Professor Picard's 2 sons, Paul and Donald, are in the foreground. Takeoff is at 6:58 a.m. at Dearborn, Michigan. Professor Picard is inside, and his wife is atop the gondola, watching for the signal from Ed Hill to know when to cut the 4 ropes. Now they weigh off, taking out a little ballast until they're just light enough. Now the ropes angle a little to the side. The balloon is being blown by the wind, and as they cut the ropes with the pyrotechnics, the gondola arcs back towards the ground. "Get under the balloon and push them up," comes the cry from the gondola. The top of the picture shows that the balloon is free of strain, so that there's no stress on the material. The top of the gondola is painted white and the bottom black to control the temperature. The outside temperature is freezing, while it's a comfortable 67 degrees Fahrenheit in the inside. The gondola is only 1/8 of an inch thick aluminium alloy. They rise at 200 feet per minute. After they get above the clouds, the ambient pressure is so low that their onboard supply of oxygen begins boiling too rapidly. They close the doors to hermetically seal the gondola. The environmental control system, which they call air conditioning, consists of liquid oxygen for breathing, a barometer, thermometer, an electric fan to circulate the air, silica gel to keep it freshened, alkali to absorb carbon dioxide, and anhydrous magnesium perchlorate to absorb moisture. The air is tested throughout for purity, and it's found to be in very good condition, which is more than could be said for the wireless. This is the shoreline of Lake Erie. Clouds over the lake are higher than over the land. And here is the balloon in a photograph taken from the ground. Looking up through the top of the gondola shows how the balloon breathes as the air forces its way in through the open appendix. There's no gas present at this time as the descent begins, so they land ostensibly as a hot air balloon. They bounce along over the top of the clouds below 10,000 feet. They listen. The hatch is open. Finally, they land in some trees after dropping 800 pounds of ballast. The balloon was punctured by trees. Trailblazers.